In this tutorial, we will review how to use the capital asset pricing model to first determine the appropriate opportunity cost of capital to be used, and then to use that opportunity cost of capital in assisting a firm make a decision about whether or not to pursue a project. So, we see that our problem says a firm is trying to determine what its appropriate opportunity cost is, assuming a beta of 1.3 and a risk-free rate of 2% when the entire market is expected to earn 8%. The project should net $200,000 every year for 5 years based on an $800,000 initial investment. So the questions are, what are the opportunity cost of capital? What are the project's IRR and NPV? And should the project be pursued or not? So as always, we'll use a similar Excel-driven problem-solving process that after reading this problem twice, we will now begin to document our assumptions. So the assumptions that we will use will fall into two categories. We'll have a bunch of cash flow related assumptions that will be used in helping to determine whether or not to pursue the project, and then we will have the discount rate based assumptions that will be used to determine the appropriate opportunity cost. So as we see above, we know that the project has a beta of 1.3. The other relevant information to apply to the discount rate would be the risk-free rate, which we see as 2%, and then the market, generally defined as the returns of the Standard & Poor's 500, is projected at 8%. I'm going to subordinate those things so that we can see that they are all a function of determining the discount rate. So to answer the first question about discount rate, we will use the capital asset pricing model. The capital asset pricing model is used as follows. The rate will be equal to risk-free plus beta times the market rate minus risk-free. Now notice in my formula I have an asterisk or a multiplication sign there in between the beta and the parentheses because Excel requires that multiplication sign. You can't just use adjacent parentheses. So after constructing that, we see that the appropriate opportunity cost of capital is 9.8%. So now let's go ahead and insert our three cash flow related assumptions. We see that the cost of the project is going to be $800,000, that the cash flows net will be $200,000, and that the useful life of the project is 5 years. So let's go ahead and subordinate those and make those dollar signs. And now we're ready to move on to our standard NPV analysis. So we build our basic template, which we know is periods, followed by cash flows in, followed by cash flows out, yielding cash flows net, allowing us to construct NPV. We'll add it up to get, to construct PV, we'll add up to get NPV, and then finally we'll have IRR. So let's go ahead and subordinate or left align Alt H A L. We'll put those things back here. I have an errant line down here, so we'll get rid of it with Alt H B N. Get rid of those lines. And now let's start the build out. So we have 1, 2, 3, 4, 5 periods here. I'm going to change my orientation to landscape since I notice I'm starting to peek over onto a second page. Let's make these all a nice uniform 13 width by using Alt-H-O-W. I'm going to go ahead and center these, or at least one of them. Now let's try to do all of them, please. There we go. All right. In this particular case, because we are given cash flows net, we don't really need to concern ourselves with the cash flows from periods 1 through 5, other than at that net level. So we'll go ahead and we'll choose those cash flows net of $200,000. We'll hit our F4 to anchor it to that cell, and then we can go ahead and copy and paste that across. We know that we have then a cash flow out of $800,000. And for this one, we'll go ahead and put in our formula of equals in minus out. And so there we have our stream of cash flows. I observed last night that you guys have all gotten good at doing the NPV calculation. So in this case, let's remind ourselves the reason we are doing this is so that the CAPM can be used for the discount rate. So we'll highlight the discount rate. Our number of periods sits in the column above us. There's no payment. Switch the sign on that cash flows net. And so we see we have an $800,000 initial investment. Go ahead and copy and paste that across. And then we recall that the NPV is the sum of all of those present values. And we end up with a net present value of negative $38,000 approximately. We recall then that IRR is simply to determine what the project's rate is, and we use the cash flows net for it. And we see then that the project's rate of return looks to be about, expand our decimals here, cell is not cooperating, Alt H and G, enter, Alt H K, Alt H0, Alt H0, Alt H0 one more time, and we see we have a rate of return of 7.93%. So, by using the capital asset pricing model, we are first able to determine that a project with this risk should offer us 9.8%. When we compare that to the IRR of 7.93%, we see that our alternative is clearly the better choice. That's also corroborated by this negative NPV number, which tells us now twice over that this project is not worth pursuing.